Anonymous.
Answer your attendance. Afla. Ajmina.
SMS.
Ameya.
Pessimis.
Atulya. Atulya is there. Drishya. Jyotish. Karthik. Jyotish.
Present, Miss.
Karthik. Kavya.
Present, Miss.
Nachiketas.
Present, Miss.
Neeraj. Rangeet. Vaishnav. Vaishnav.
Present, Miss.
Anjali. Shruti.
Present, Miss.
Afla is there. Drishya. Atulya.
Present, Miss.
Karthik. Neeraj. Vaishnav. Not Vaishnav. Anjali and Vaishnav.
So Vaishnav present.
Vaishnav is there. Yeah. Vaishnav is. Okay. Yesterday we were dealing with the distance vector routing protocol. I have given you two sums to work out. Okay, we will come back to it within a few minutes. I want to explain a little more concept in distance vector routing algorithm. And after that, we will be just proceeding with the problem. We will check it whether it is correct or not. Okay, so what I was telling about the distance vector routing algorithm was, it is actually this algorithm, it is given by the name Bellman-Ford algorithm. And here what it is happening is, each node is maintaining a routing table called the distance vector. Now, once every node created their routing table, what happens is each node is exchanging the distance vectors with all the neighbors in the network. Whoever is adjacent to them, they will be sharing that information to their neighbors. And based on that, the routing table, newly they will be creating their routing table, and that information, that updation is mainly done by basis of this Bellman-Ford algorithm. Okay. Now, when you are considering this distance vector algorithm, now what is the concept is, yeah. What is the thing is, the routing table is converged in a few rounds. You have to see, maybe it will be converging in the second step or in the third step. 2 times you have to find out the routing table, and it will be converging in a few rounds if there is no topology change. Okay. Now, after one message exchange, each node knows about the nodes 2 hops away. The meaning is, if you have a node that is A, which is directly connected to B, right? And B is connected to C. The meaning is, in the first hop, B will be sharing its information to A, right? Now, the same time, C gets the informations from B also. I mean, C exchanges its informations to B. So A will get the informations of C in 2 hops. That is, this is one hop, it will receive B, and whatever is there in C, that will be received in the 2 hops. So the meaning is, each node knows about the nodes 2 hops away, if after one message exchange. Now, suppose if C is connected to D again. So in the first exchange, C's information will be getting in D. Now in the second exchange, D's information will be getting to C. But when you are considering A, how many hops away it is? It is 1, 2, and 3. The meaning is, each node knows about the nodes 3 hops away when you are doing the 2 message exchanges. Understanding the concept? if you are doing one message exchange, you are coming to know about the two nodes which are away from that particular node. And if you are doing two message exchanges, you are coming to know about the node which is 3 hops away. Okay, and it will be continuing. Now when you are considering this distance vector routing algorithm, you have to remember some points. Now what is that is, when does a node send its partial routing table to all its immediate neighbors? Now I have told you the neighbor, each of the routers, they have to share their information to the neighbors, right? So, or they have to share their routing table. I have told you the first 2 columns of the routing table is being shared to the node, particular node. Now, when does it happen is, you can do it in 2 ways. 2 types of exchanges or 2 types of updates are possible in distance vector routing algorithm. One is the tape is sent both periodically. Periodical updation is there. Now the second one, when there is a change in the table. Now what is this periodic update? Periodic update means every node will be sending its routing table every 30 seconds to its neighbors. That means it is based upon the protocol. So if you are, I have told you, you have got many routing protocols like RIP, OSPF, etc. So based on these protocols, each node, will be sending its routing table to its neighbors every 30 seconds. So 30 seconds, they will be sharing that information. So that is called it as the periodic update. Okay, now you have another update called triggered update. Triggered update means a node sends a 2 columns routing table to its neighbors anytime there is a change in its routing table. Whenever you are having a change in the routing table, they will be sharing that information. And that is called it as the triggered update. Now, triggered update can happen in 2 ways. Now, when that updation is being proceeded. When a node receives a table from the neighbor, resulting in changes in its own table after updating. See, whenever a node is transferring its routing table information, and if you have a change in that, you will update your table, right? And also the second possibility is if you are having a failure in the neighboring links. If you have a failure in the neighboring links, that also the distance will be counting as infinity, and that information will be also shared. So that type of sharing is called, updation is called it as the triggered update. So 2 types of updations are there. One is the periodical update. That means every 30 seconds, each router will be sharing its information to its neighbors, right? Now, second one is the triggered update. Triggered update is nothing but whenever you have a change in the routing table, you will be sharing with your neighbors and they will update their routing table. Okay, and if something happens in the node, if a link fails, that information also will be getting updated. Okay, so you have 2 types of updates. Now you have a disadvantage in this distance vector algorithm. Now what is that problem is instability. Instability, meaning the network which is using this protocol can become unstable. You cannot always tell that it is a stable algorithm. It is, instability is there. It may become unstable. So you can call that problem as count to infinity problem. Very, very important. Sometimes it will be asked, what is defined count to infinity problem? So this is one of the important issue in your distance vector routing algorithm. Now counting to infinity, you have got another name called, it is also called it as a routing loop. Okay, so routing loop usually happens when an interface is down, or if 2 routers are sending the informations at the same time, you can also call it as the routing loop. So these are the routing loop means 2 cases. One is if the interface is going down, you can call, each router will enter into that state or the looping takes place, or if 2 routers are sending updates at the same time, That form also you can call it as routing loop. So this is the problem that is associated with distance vector algorithm, count to infinity problem, right? Or you can call it as routing loop or two node instability. Now what is this exactly? Now consider this figure. You can just see a figure here. They called it as the two node instability or count to infinity problem. Now you can see here, see, I am having three nodes here, node X, node A, and node B. Okay, you are having a system with three nodes, X, A, and B. Now, at the beginning, assume that both the nodes, that is A and B, they know how to reach node X, right? So initially you assume that the nodes, that is A and B, they know how to reach X. So here their routing table is shown. So the destination is X. You can reach X from A with a cost of 2. That is being written in the routing table. And the next hop is the same. So leave it as, that there is a hyphen there. Okay. Now, if you are considering this B, B knows that it can reach X through A itself, A only. And so the cost is 4 plus 2, which is equal to 6. Okay. So initially the routing table, both the nodes, they know that how to reach X with a distance of 2 and from A and with a distance of 6 from B. Now, what happens when the link between A and X fails? What happens? Suddenly, what happens when the link between A and X fails? So what A will do? A will changes its table. Your destination is X. Your cost is infinity now because you don't have a link from A to X. Right? So node A changes its table. Now, if A is sending the information immediately to B, now everything is working properly because B is coming to know that there will be no link to A and it will be updating as accordingly. Right? Now, but what happens if B is sending this information to A in firstly? I'm telling A updates its table, but before A is sending the details to B, what B will do? B will send it to A. So imagine both this is if B sends its routing table to A before receiving A's routing table, then you will have a confusion there. Okay, so what node A will think now? So node A thinks that B has found some way to reach X. Right? So what this information, that is X6A, it has been received to A. So what it will be doing? So you are knowing that you can reach X through B with a distance of 10. Okay. So A is not sending its table to B, but before that B has sent to table A, node A. So A is thinking that there is some way for B to reach X. So what A will be doing? A will be updating its routing table. Right? So A thinks that it can reach X through B with a distance of 10. Right? So you are receiving it based on the triggered update strategy. So what A will do? A will send its update to B again. Right? Now B thinks that something has been changed around A. Now what B will do? It will update its routing table. So this will be going on until it reaches infinity. So both are updating, they are having the confusion that there are some way from B also, from A also to reach X. Right? So the cost of reaching X increases gradually until it reaches infinity. Now, at this moment, what both the nodes will come to know is that you cannot reach X. right? So the system is not stable. So I'm telling instability, that is the major disadvantages of distance vector algorithm. So what node A is thinking? Node A thinks that the route to X is via B, and what B thinks that the route to X is via A. So they have a confusion, A and B, right? So if A receives a packet, if it is the destination is towards X, now what it will do? It will first go to B and then come back to A. Right? Similarly, if B is receiving a packet which has to be transferred to X, now what it will do? It will first go to A and then it will come back to B. So you are having the interchanging is done between the nodes. So it is also called two-node instability. Okay, so this is the main drawback of distance vector routing algorithm. So what I have told is the main issue is called it as the count to infinity problem. Now what is count to infinity problem? Count to infinity problem is, suppose if a link is getting failed between two nodes. Now if three nodes are present in a network, and if one is coming to know that, okay, the link is there, so they will update its table. But before that, if it is receiving the updation from the neighbor node, you will have a confusion there. So they will be going on adding the cost. They think that they have got some other way to reach the source node. And so this will be going on. And finally, up to once it reaches, the cost reaches infinity, they will come to know that, okay, there was no link between A and A. And finally, you can tell that the system is not stable there. Okay. Now, what is the solution for this? How can you avoid this count to infinity problem? Now you can do it by two methods. One is defining infinity. So the first solution is to redefine infinity to a smaller number, maybe such as 100. The meaning is once it reaches 100 value, you can stop there. So it is not going, I mean, the infinity value, you are keeping it as 100. Right? But if later you will be studying, I have told you the routing information protocol is based on distance vector routing algorithm, and there they have defined the infinity count as 16. That means 16 hops or 15 hops only they can make in a network. Okay, so the first thing is you can avoid this two-node log loop instability or the count to infinity problem by first defining the value of infinity to a number. Okay, so the disadvantage of if you are defining the infinity like this, the disadvantage is the distance vector routing, it cannot be used in large systems. Right? Now the size of the network, it cannot exceed 15 hops. I have told for distance vector especially, it is kept it as 16, making use of this RIP protocol. So you can move the network only within, I mean, you can take only 15 hops in that network. So it cannot be used in the large systems. That is one correction, how you can correct the count to infinity problem. Now, what is the second solution? Another solution is called it as the split horizon. Now, what is the split horizon? So here, in this case, instead of flooding the table through each interface, each node sends only part of its table through each interface. The meaning is, I have told you, you had three nodes X, A, and B. So first, initially, they have exchanged the informations that they can reach node X with a distance of, see, this is here. A is sharing information to B, and B also shares the informations to A. So they, what is the distance actually? X2 dash and X6A, right? So that information is known by both of them. Okay, so that information, so once B understands that it can reach X only through A with a distance of 6, what happens is it is not sending that information again. because it is understood. It is through A only it can reach the node X. So it is not sending that particular part of the routing table. So what happens if the link fails immediately? If the link fails, A will update the table. So A will be sending the details to B. So B comes to know that, okay, the link is failed there. So the distance it is equal to infinity. Right? So in first update only, the node B will come to know that there is no path to X between A and X. Right? So like that also you can correct that count to infinity problem. Okay, so what I told is here, if based on this table, node B knows that the optimum route to reach X is via A only, and it does not want to advertise that information again. I have told you the full routing table, they will be sharing it to its neighbors. So what they will do is they will eliminate the last column in the routing table, because A knows that B can reach, the only route to reach X is via A itself. Okay, and A knows that also. So taking that information from node A, modifying it and sending back to node A creates the confusion there. Now, if B is eliminating the last column in the routing table, now if A is having a value of infinity in its routing table, now what B will be correcting its routing table in the first update itself. The meaning is the system has reached a stable state. It is not going to an unstable state. Understanding what is split horizon and what is this count to infinity, defining infinity. So these are the two solutions to eliminate the count to infinity problem. So count to infinity, it is also called it as two-node instability. This is happening when a link between two nodes is broken or it's not there. So the cost is keeping it as infinity. This happens because there is a delay in sending the correct information from that respective router. By the time it is sending, the other node has sent the information. So they will have a confusion there. So in order to avoid that, two methods you are making use of. One is called the count defining infinity, and another one is the split horizon. Defining infinity means that infinity value you are setting to a number. In distance vector, that number, making use of RIP protocol, that number is kept it as 60. The meaning is it can take 15 hops. Okay, the routing can be done through the 15 hops to reach the destination. So this type of distance vector routing, it is not used in large systems. Okay, now the second case was the split horizon. Now split horizon means once they know, okay, the distance to a particular node is that one. Now they don't need to update it. They don't need to advertise that information again. So other than that information in the table, they will be exchanging it. So if a link is failing immediately, then both will be updating its table. So the system becomes stable after the first update. So both A and B knows that X is not reachable. Okay, so that is the concept of split horizon. Understood? What is split horizon? What is defining infinity? And what is count to infinity problem? Usually it will be asked, what is the drawback of distance vector routing algorithm? How you can eliminate it. Understood? So when it is asked, you should be explaining with the help of the example. Count to infinity problem, what happens if the cost is infinity, and how the updation is happening, and what is happening to each node, how it is becoming unstable. So all the reasons you have to write it. Now how you can eliminate this? By two methods. That also you have to explain in a beautiful manner. Understood? What are the drawbacks of distance vector routing algorithm? Yes or no?
Yes, miss.
Okay. Now we will go back to the problem, the homework problem, what I have given, because the next topic is link state algorithm that we will be dealing tomorrow, because that is little theory part I have to explain more, and then we will be doing a problem. So the time won't be sufficient. So we will go back with the problem, homework problem. Yes, who will be telling that answers of the homework problem? Afla. Afla was not there yesterday in the class, last hour.
No, I'm absent.
No. Ajmina, the homework problem I have given, no? This one. This one. Did you complete it? Yes. Okay. Now what is the table for A? Final table for A.
A0A,
A0A, okay.
B1B,
B1B,
C4B,
C4B,
D8C,
B8C or B you will be getting. What others got? Amaya, what you got?
D8B.
D8B it will be. The nearest hope you take it. I think you have a
Okay.
confusion. Yeah, nearest hope is B. Okay, you take that. Then last one.
E10B.
Okay, E10B, right? Now next one, Drishya. You can answer for B. Drishya is there? Drishya, yeah, tell me. Did you complete it?
A1A,
A1A,
B0B,
okay,
C3C,
okay,
D7C,
D7C, okay,
E9E.
E9E. Everybody got that answer? It is A1A, C3C, D7C, and E9E. Rishya, I mean, so others, did you get it? Karthik,
Yes, miss.
Yes, miss. Actually,
okay. Now, what is
it
the
is
table
getting.
for C? Kavya can tell.
A4B,
A4B, okay.
B3B,
B3B,
C0C,
okay,
D4D,
okay,
E6D.
okay, E6D. Hope everybody got that answer. No, Neeraj is there? No. Vaishna,
Yes, miss.
Undo. Uh-huh.
On
Tell the answer for D.
D,
Tell the answer for D. What you're getting.
table answer.
Ah,
A9C.
correct ano? Nachiketas. First value correct ano?
A.
Ma'am,
Hmm?
9C,
A?
9C,
9C.
No, it won't be 9. It will be 8.
80. 880.
8C.
8C.
Yeah, A8C it is. Then, other one?
B7C,
Neeraj, tell the answer. A8C, then what is the next value?
A.
A is finished. ചെയ്തില്ല. ചെയ്തോ?
ചെയ്തിന് സർ. B7C.
No. B, is it B or D?
B7C അല്ലേ?
B for ball or D for doll? You're telling B or D?
For boy.
I-
B for boy. B for boy.
B for boy. Okay. B7C.
7C.
Okay. Then.
C4C.
Okay.
D.
D.
0D.
Okay.
E.
Hmm.
E2E.
E to E. Did everybody got that? A8C, B7C, C4C, D0D, and E to E. Right? And the last one, Vaishnav can answer.
A10B,
A10B,
B9B,
B9B,
C6D,
C6D,
D2D,
D2D,
E0E.
E0E. Is it correct? Every others?
Yes.
Yes, miss.
Okay. Now, how did you
Yes,
do
yes.
it? With the first method or the second method, what I have told? The first method, that is making use of Bellman-Ford algorithm, I mean, writing the cost and all, or the direct method?
Direct.
Direct. You be careful because read the question, okay? If it is asked using Bellman-Ford equation, you have to just write that equation and just solve it. This we can check it, I feel. So depending upon the marks also, you just answer it. So everybody, did you do the second method or only Kaveh has answered now, right?
First method. Bellman.
First.
First method. Okay. Second method, if anybody had to clear that second method, I'll be just explaining once more the second method. Do you need that? The second method clarification.
Yes, miss.
Okay. I'll just tell it. This was the problem, right? So here, this is the network, what it is given for me. So I have to find out, simplify it using distance vector routing algorithm. Now here, what is the main thing? If you're doing the second method, making use of the second method, you should understand one thing. Your cost and the number of intermediate nodes must be minimum here. The cost and the number of intermediate nodes must be minimum. Maybe you will be getting the same cost and but different number of intermediate nodes. So the minimum one you have to consider it. Okay, that is the meaning of that. So first, initially, what I have is, okay, what I'm doing the routing table for A. So I know what are the cost here. That is, I'm having the destination, the cost, and the next home. So for A, who are the neighbors? I'm having B, right? Then C and D. B, C, D are the neighbors. Now I am at A, I want to reach B. Now what are the possibilities? So I can reach directly to B. B is my destination now. I'm writing with respect to destination B. So A can reach B with a distance of 2. A to B, the distance will be equal to 2. Now what is the other possibility? I can go from A, B, C, and B, right? I can go like that, and I can also go A, D, B. This is another possibility. So if I'm making use of A, D, B, the cost is equal to 8. The cost will be equal to 8. And if I'm making use of A, D, C, and then B, the cost will be equal to 50. So which is the minimum cost here? 2 is the minimum. So I will be making use of that C. The cost will be equal to 2, and the next hope will be B itself. Right? So the destination B is finished. Now I have to come back to C. Now what are you have to just check what are the possibilities of E. If I'm just considering, if I'm considering C as my destination node, what are the possibilities to reach from C? A. Now, what are the possibilities? I can reach A, B, C, I can reach. I can reach A, D, C, I can reach. Now I can reach A, D, B, C also I can reach. Right? Now find out what are the costs. If I'm making use of A, B, and C, the cost will be equal to 3 plus 2, which is equal to 5. If I'm making use of A, D, and C, the cost will be 11 plus 1 will be equal to 12. Now A, D, B, C, the cost will be equal to 15. So what is the minimum cost there? Minimum cost will be equal to 5. So I can write B, I have just got it as B2B. Now C, what I'm doing is, it is the minimum cost will be equal to 5, and router B, through B only I can reach in a minimum cost. Understanding? Yes or no?
Yes.
Yes, okay. Now I have finished C, right? Now what is the next destination? My next destination is equal to D. Now what are the possibilities of reaching D from A? Tell me, anyone, what are the possibilities? Yes,
AD,
AD, okay, with a cost of 1. Then,
ABD,
okay, ABD, the cost will be equal to 9, right? Then
ABCD.
ABCD, the cost will be equal to 16. Now which is the minimum cost there? Minimum cost will be equal to 1. So you will be getting it as D1D itself. Directly, the direct link is D, so it will be D1D. So the routing table for A will be A0A, B2B, C5B, and D1D. Okay. Now what you have to do? Proceed it for router B. B you have to consider. Find out, write down which are the destinations. Now the destinations are A, C, D. These are the 3 destinations, and see which is the minimum path in this case. Okay. Now tell me which are the possible paths available for B. If my destination is A, which are the possibilities? Do it and tell me. Yeah, who will be telling? Rishya can answer. I am at B, I want to reach A. Now what are the possibilities? Rishya. Not there. Then Adulya.
Yes, miss.
Yeah, tell which are the possibilities to reach destination A.
BA
BA, okay, with a cost of
2.
2, right. Another one,
BDA
BDA with a cost of
8.
8, okay. The third one,
BCDA
BCDA with a cost of 15, right? Now, which is the minimum cost? Which is the minimum
BA2
cost? BA. Okay, so it is your destination is A, your cost is 2, and you are having a direct link. So the next stop is A itself, A to A. Now, so find it for C. Your destination is C. You have to reach it from A. Now, who will be telling that? Nachiketas, make it fast.
B to C,
Yeah, B to C.
BC,
Yeah,
BDC,
BDC, right?
11 plus 7, 19.
Yeah, BADC, right? Now, which is the minimum
BADC,
cost there?
3.
3. Okay, so C3C you will be getting. Since you have a direct link, directly you can write it as C3C. Now, Karthik, make it fast. For D, you tell. Hmm? Your destination is D. You want to reach from D. You're taking time. Other staff has joined, so I have to complete it. Okay, Kavya, fine, finish that.
BD 7,
Okay, 7, right?
BAD 3,
Yeah, 3,
BCD 14,
14. Which is the minimum path?
BAD 3.
D with a cost of 3. So your destination is D, cost is 3. Via A, you can reach it. So you have completed for B. Similarly, you do it for C and D and see what table you are getting it. Okay. So if anybody is yet to complete, you have to complete it and tell me the answer tomorrow's class. Okay. Okay. Thank you. Tomorrow by sharply by 8:30, join the class.